All right, so here we are. Spring break ended. We just did sprint 2 posting. We're starting sprint 3, which can be about animation. So you got 1 week, 2 week, 3 week. And we post up week 3 the Sunday before class. So it'll be the 14th. April 15th is a Monday. We start sprint 4, 1 week, 2 week, 3 week. And then we post up sprint 4 that Sunday before. That'll be May 5th. And now I'm taking a vote in class. So we could just do the final right here for an hour and then not come into final exams. So we have 3 weeks to do sprint 3. 1, 2, 3. Sprint 3 is that Sunday. Then sprint 4, 1 week, 2 week, 3 week, we drop. And then during this week, you just have to study as well for the final. Final's multiple choice, short answer just on like C#, Unity, user interfaces, game objects, input like mouse input, keyboard input, animation, which you'll be covering. Nothing outside the scope of the class. So do you want to just drop sprint for that Sunday, May 5th, and then come in here May 6th for an hour, take the exam, and then you're done? Or do you want it that week to prep and take it later? So if you want to take the exam May 6th, you can raise your hand. All right. So the other classes were like that too. So I'll get up a review for the final exam. It's nothing crazy. And as you're coding up your project, you're basically practicing for it anyway. It's a very practical oriented exam. Covering how to create these interactive experiences, thinking about user flows, diagramming, and then coding up these things. So the other issue I had with this is that a few people had scheduling issues. However, the exams were scheduled. They have other exams or what have you. So this might be the best option. And it seems like all the classes voted for this. And then so I'll do a posting, and if anyone has issues, they can come in and talk to me. All right, so that's it. 3 weeks, sprint 3, 3 weeks, sprint 4. Just do the final, and then we're done. So we'll have like a 50-minute lecture, and then I'll do, I'm creating the video for it, get that up, and then I'll have some type of additional. I'll probably have another lecture video just on the sprint. Like, this is what I'm making, this is what you'll make. So this is very much in line with sprint 2, except I'm pulling back more. I'm not having you follow me as much. So maybe I'll do a few features and ask you to do define out twice as many features. So same guidelines with diagramming out the user flows, coding up your ideas. In this case, we're focusing heavily on animation. So that's what I was just cleaning up what I was doing in the other classes. So I'll just turn off time destroy. So here's what you're used to, these static objects. And here's just some objects that have repeatable animation on them. And then this is some things I have to talk about is some aspects of animation. If you do choose to animate them, they can't be driven by code as much. So we'll cover this in class. But as you see here, some of my different paint strokes are now animated. They have this feature of motion, or they have this feature of change of parameters, change of values over time. So we have our static paint stroke on the left and the animated ones on the right. Now you don't have to just choose to animate the paint strokes. You can animate additional features on your user interface. You can animate game objects that already exist in the game world. So I showed you how I built this clock, and I'm basically driving it with animation, with code that's moving parts of it, which is animation. And you can create other objects that are either moving in the environment with code or with animation. So anything that you can use this animation system with, you can drive with code as well. It's just that it gets the math, besides doing basic animation, are like moving stuff back and forth that we've done with like distance and distance change, or driving a rotation of like a clock part or something. When it gets more complicated than that, that math gets a little intense, to code up by hand. So there's these animation systems which are more design oriented, more artist friendly. You don't have to code to create these animations. So it's more like exploring different ideas, seeing what works, what doesn't work quickly. We're going to cover this animator, which is at the bottom, which has different states or different animations that you can switch between. And the animator, you can call like triggers or set changes. So like if a user does certain input, certain amount of time passes, certain objects move certain distances, they overlap, or whatever you're looking for. You're doing your checks in the update loop. If certain things happen, you can set calls or set triggers to the animator to switch out different animations on different game objects. So the most complicated scenario might be like character animation. So in a game where a character is like running, walking, ducking, crawling, shooting, jumping, swimming, or whatever, all these different states that they can be within, there's 10, 20, 30 different animations based on different conditions that the player or the object is within. But we're just looking at animating either paint strokes or stuff that exists in the environment or stuff that exists in your user interface. Now, any change of state is considered an animation. So if I go to the drop-down list, even this opening and closing of this list is an animation. An animation is a change of visual information meant to convey to the user that something has happened. There's new features, new ways to interact with the app, new information has been created or destroyed, or whatever the situation is that you wish to inform the user or have the user interact or be just entertained. So in this case, this drop down, just opening and closing this list, I'm just going to clear out this stuff right now. So even if this list open and close like instantly, there's no nice fade ups. You notice how it kind of fades up and fades down. There's like the top part kind of grays to show that it's like active or inactive. All those are nice additional overlaid animations that give more information to the user. But even if this just open and close really quickly, that's still an animation. Even if it's one off, one out, like on off, it's still a change of visual information. Dragging these sliders, it turns gray, it's moving left to right, the fill on the left and right is changing. Even that's an animation. This number, this text that I'm actually updating with just updating strings, that's an animation. These sliders, as this number changes, which is just some math, I'm just feeding in 0 to 1, multiplying it by 100, cutting off the ending part of it. That's still change of information. That's still animation. All right. We're looking at this kind of 3D stuff and what have you, but still 2D animation, 3D animation, text, it's all animation. So as you see this, maybe hopefully gears start to turn in your head what you can do, what you want to do. These are just loopable animations, one animation playing over and over and over again. You don't have to make them loopable. You can make them do different things over a certain amount of time and it stays in a different state. It's very common to be like, oh, an opening animation where something is fading up and then it's in its active state and it's showing something, or it's like pulsating to show you it's alive. And then maybe its disabled state, it fades out and it's not animating anymore. And then there might even be like enabling it, disabling it, maybe even turning it off, where you turn off the graphics. Maybe the object still is there, but you turn off the render or you fade it out and you disable its interactivity. And then it kind of flows through these like 4 or 5 animations. And that's why these animators, which we'll get into, are called state machines. They're managing these different states that these objects can be in. In this case, most of the state is this whatever animation should be playing to the user. So before I move on, is there any questions?
Just like for the sprint, how many new features do you have to do?
Yeah, I'll do the video, like the online video I'll do with that. Like, let me start building some stuff out, see how much work it is. And then I'll say, okay, you can do about this many animation features. So if you want to, you can create new game objects that aren't your paint strokes, that are just doing stuff in the background. Or when you paint something, if enough you're painting, maybe something else turns into an active mode. Maybe you have a UI element that starts filling up and like pulsating when there's more objects on the scene to show that, well, you're getting up too much, you should delete stuff, or whatever you care to. But as far as the specifics of the sprint for these 3 weeks, I don't know, but I'll create that in an online video. But it'll be very similar. The amount of workload, you have to define some new user features, you got to make your flows. What does the user do? What type of information gets presented to them? What type of feedback or processing is happening? What decision points are there? And then you code it up. In this case, it's probably going to be lighter on the coding and more about using these animation systems. And then maybe for Sprint 4, we'll start like taking all your interesting animations and seeing what can be carried over to code so that they can be more dynamic. So the animation system allows you to do very interesting things quickly that you just couldn't do straight with code, because I couldn't figure out the math that's going on right away. But if you like mess around with the animation and you're really happy, all you're doing is setting changes to different variables, which I'll show you later on. In that now you want to make it more dynamic. It's not just playing this animation. You can bring it over into code and have the user mess around with it and make it more interesting. So that's probably going to be Sprint 4 as I'm talking about. But is there any other questions? All right. So I'm going to close these out. And I think this cube is just a basic cube. And let me just drag him in. I'm just going to reset this. I'm going to take off the animator. So this cube was just as it was when you saw it. I'm going to click apply. I'm going to click back on this prefab and show you that it's just what it was, just a render and a collider on it. And I'm going to delete this one from in here. And this should be how you're used to seeing Unity. So we have our project view up here, which has all of our external files organized into references that are on your file system. We have our hierarchy here, which is all the information in this Unity scene that is what your working app is going to be. So when you build it, it's building whatever this Unity scene is. We're not doing multiple scenes right now. That's how they kind of like load in level 1, 2, 3, or have like a main menu or a splash screen. We're just doing one part of an app. So one Unity scene, which is currently open, but this exists in my scenes view here. We have our inspector, which shows kind of all the attributes, the components of whatever object you have clicked on, our scene view. So notice that I've organized my project. Hopefully you've been organizing yours as well. You see that the number of external files that you start generating starts getting overwhelming. So as you notice here, I have the materials folder. All my materials are shown in here. All the different color properties that these objects can have. We have all our different prefabs. These are just game objects that you've been creating that have different render attributes or colliders or your own custom scripts that you're creating. And you save them out as a separate file so that you can instantiate them or use them dynamically based on whatever's happening in your application. You have your Unity scenes, these parts of your application kind of you're building together. And you have your scripts. It's all your C# scripts, your custom functionality, right? So to start with, to understand animation, we're going to have more files. So you should create a folder. Create folder. Call it animation. So I happen to have right-clicked on assets here, done create. But you can also go up here to the create menu. Notice it's the same. And you can also go over here to assets, create, all the same stuff. So in this class, we're going to be creating a folder, and we're going to be creating an animator and an animation. I like to right-click where I want to create, because whatever you create there gets placed in that folder. So after you create this animation folder, we'll just say right-click, create, and come down here to animator. And you can create that and just call it cube or whatever object you're working on, a sphere, capsule. Just call it whatever the object is. All right, so I'm going to create an animator controller and just call it cube. So the reason for that is that you can see that you need an animator for everything that you're going to animate, and there's a lot of them, so you need to name them something that you can reference really quickly. And I'm going to go into my prefabs folder. I'm going to grab my cube or one of my prefabs, and I'm just going to drag it into my scene. And I'm going to reset the position. So it's just kind of sitting here at world space 0. And I'm going to drag the animator onto my cube object, and it will connect as another component, just like a script. And so we now have an animator connected to our game object, and the actual animator is this one. And so this is a little icon that means animator. So it's like a manager object. It's going to manage all the animations on your object. You can have multiple animations, and you can kind of set triggers. You can set situations when different animations get played, when you should transition between them. So once you have a manager object on your object, a manager component on your object, you can go to Window, and here under Animation, we have the Animation window and the Animator window. So these are some new areas of interactivity and multimedia that we're going to get involved with. So for now, I'm just going to open up Animator. I'm just going to pull it down here. And the only main area we're looking at is this kind of graph area. And I have 3 states. I have any state, entry state, and exit state. So when this animator first becomes alive, first activates, we enter the entry point, and we have to enter a state. So we're going to create an animation, and that's going to be our state that we're going to go into. These other ones are for more like advanced features we don't have to worry about. Just know that an animator controls all these different animations on an object. There's an entry point, and we have to go somewhere. We have to go to an initial animation, an initial state. So with that, I can open up the animation window. And think of animations as like creating individual states, and the animator controls those states. So we have everything set up now to create a state, our first state. So it says it has no object selected, right? So I have to go over here and click on it, which is why I'm working on an instance of a prefab in my scene. You can just create a game object, drag in something free from the Unity Asset Store, something. You just need something to have an animator on it in your game scene. Say, okay, to begin animating, create an animation clip. So we're going to click Create. We're going to go to the animation folder, and we're going to do something to it. So I got to call it, usually I call it whatever the object is, cube, and then some verb, whatever the animation is. So it might be idle, intro, starting, closing, warping, dancing, whatever it is that you're trying to do. So I'll say bounce. I'm going to try and make it like try to feel like it's bouncing. So cube bounce. I do that. So I have cube bounce here. This is the symbol for an animation. It's got a little play button that it's playing. That's what an animation does. By default, it loops. So that's when you saw before the animation just kept playing over and over again. Most of the time, you have loopable animations, but sometimes you just want it to play once and then stop. Just know by default it loops, and you can turn that off if you don't want it to loop. So I first click on an object in my scene that has an animator on it, and you have the animation window open. So go Window, Animation, and then there'll be it'll say something. It'll say like to begin animating or to create an animation, click here, and there'll be a button that says like create clip or create animation. Does it not show up for you? Yep. So click create, navigate to the animation folder and name it something. So usually I call it like a noun verb, whatever the object is and whatever it's doing. So the reason I do that is because now you see all the cube actions are kind of nestled with the cube animator. Now we have different animations, different animators, and they kind of alphabetically align themselves with them. So click on my cube. It shows what animation I have. Here's cube bounce. And when you have something clicked on, if I click off it, please don't have animations, but when you click on an object, you see this add property button. So I click on it, and it shows the components on this object. So underneath the components are going to be its exposed variables and parameters. So just like you created a script, and then you made variables public, and you were able to mess around with those variables in the inspector. And then if you really liked it, you can make your own little user interface in the inspector, and you can start changing stuff. We're doing the same thing. We're just changing variables, but the state gets changed over time. It's just not that you're sitting there and trying to find everything that feels correct as like a static object. We're actually messing with those variables, but they get messed with over time. And like the next stage that you're used to is you like promote them into the actual user interface that the user uses. In the user interface, every time it's manipulated, touched, it like calls a method, and we change some values. So that actually is as you're messing around with the user interface and you're changing stuff, say the scale. So if I paint here, let me just turn off the destroy, and I mess with the size, this is basically animation right here. It's just user-driven animation. I just don't feel like doing this over and over again to have an animation. I want the software to do that. But this is what it's doing. We're initiating a change in value or variables over time. But instead of having the user do it, now we're going to create an animator that just does it over and over and over again. So add property. So under mesh render, we can mess around with the color. We'll do that later. Collider, we're not really going to mess around with, but the transform. Notice what we have here: position, rotation, scaling information. You've already messed around with this just with your own code, but it's right here. There's a component. It looks at all the components of the game object and then shows you what's publicly available to mess around with. You can actually create your own scripts, make stuff public, actually appear. You attach your script to the object, make it a component, and whatever you expose can be messed around with in the animator. So let's just say we're going to mess around with the scale. So here we have the icon for the transform, the name of the object, the name of the in this case it's not the component, this is the field or the variable. So if I click the arrow down, here we have scale X, Y, and Z. So we're looking in this window. One thing to note is the window is taken up with this kind of this sheet, these vertical lines. So an animation by default is to 1 second. So we have it starting at 0 and going to 1. You can make it longer, shorter. You can do whatever you want. Just it defaults to 1 second because that's a very common animation time. Notice that the samples are at 60, and notice that these little partitions go up to 60 for 1 second. So these are 60 frames per second. Very similar to how there's 60 seconds in a minute, 60 minutes in an hour. This animation package chose to divide up a second into 60 parts because we're all familiar with 60 seconds in a minute, 60 seconds in an hour. Each frame is just a drawing to the monitor. So if you ever gone and bought a TV or a monitor and you see these hertz ratings, 60 hertz, 75 hertz, 90 hertz, 120, everyone's flipping out about 120 frames a second, or refresh rate. So this is how often the image is updated on the monitor, on the TV. So that's what this hertz rating. Hertz just means how many times a second. So we're dealing with FPS, frames per second, our frame rate, our hertz, our refresh rate. How often does your graphics get refreshed to the monitor? So the human eye, when it sees a frame rate over 15 per second, so 15 frames change per second, you start to perceive motion. Even though all it's doing is changing out a static image, if it's changed out quick enough, to us it tricks our mind and it looks like motion. So I don't know if you've seen the birth of animation. It's like this kind of carousel with like a horse cut out around it, and the horse is in a different pose. And in the middle is a candle, and if you like spin it from the viewer's perspective, looking at the side of the cylinder, and it's moving quick enough, meaning the horse image is being refreshed, it looks like the horse is trotting or running. So this is basically what we're doing. It's just we're doing it digitally now. So in this animation, we're going from time 0 to time 1 for 1 second. We have 60 frames. And we have a tick here and a tick there. These are called keyframes, or keys, these little diamonds. So if I shrink it up, you see scale has a value to begin with and a value to end with. And if I open it up, it's really 3 values. It's a vector 3, x, y, z. Now as I scrub through the timeline, I'm left dragging. This line is moving with me. This value here is updating the number, the actual frame that we're on. In this case, we go from 0 to 60. What should the values be? So the only thing that we're currently animating on is the scale. And this tick here says it's all at 111, and this tick here says it's all 111. The Unity system does this by default. It reads in, okay, you want to animate on the scale. What's the current value of the scale? Happens to be 1. That's just what my prefab was set at. Normally, you start at a value and you end at a value. And if you're looping, normally you want your start value and your end value to be the same, so that when it's played over and over and over again, the start and end, if they're the same value, it looks seamless. It just keeps flowing through over and over again. So this is why you don't have to have these values. You can delete them. I can take this key and just delete it. But right now, I want to keep it. I'm going to undo that. I'm going to move to midway through, 30 frames in, and I'm just going to update each value to half a unit. Notice how a diamond at each value is added as I change that value. And if I zoom in here, now it's animating. So if I click play, we have a loopable animation. And it only feels nice and seamless because it's going from 1 to 0.5 to 1 over and over again. So if I took this ending frame here and made this like 3, we're going to get a pop. Because it ends at 3, and then all of a sudden, instantly, the next frame it goes to 1. So normally, you want a looping animation, and normally you want your start and end to be the same. Now notice how the numbers are running, and we're running through the frames, and notice up on my component, these values are actually updating. So if I click play and say, okay, this is at 111 and 30 frames in, or half a second in, they're all at 0.5. But midway through this change, or quarter through the whole animation, we're at 0.75. But I didn't have to go through each frame and mark that number. So you drop down the keyframes of what you definitely want, where you want it, and the computer will interpolate what the value should be on during all those frames. So it said, oh, okay, at time 0, we're at 1. At time 30 frames, we're at half a unit. You're currently at 15 frames into the animation. That's halfway through 0 and 30. Let's divide this change. So if we're going from 1 to 0.5, half should be 0.75. You didn't have to go through and do that. So this is what's called interpolation. So notice how I just marked one frame. There's really 3 frames marked. Like this is the value at the beginning, this is the value at the middle, this is the value at the end. But the actual animator did the work of placing those keys at the beginning and the end. I just placed one in the middle. So what the amount of work I did is I just specified a value in the middle, and it went through 60 frames of animation and figured out what all the values should be, all that data. So it's kind of similar like when we were painting the paint stroke at a certain distance, and then we had like that distance change value, and they kept moving it. So this is doing that for us. It's just figuring out what the incremental changes should be, so that when it's played back to somebody, even though these are just static images over and over and over again, it looks like motion.
I'm guessing if you wanted to just like actually just do step by step, or like there's 1 and then a half is 0.5, then you actually have to put in every keyframe to keep that one.
Right. So and if you did again, anything you do here you can do in code. Behind the scenes it's code. So you can say, okay, whenever this prefab is spawned, you can actually make a little script that has a little update loop. And every update, we're shrinking or growing the scale between 1 and 0.5. And get this, there's actually scripts called ping pongs that you can actually say, okay, I want to go between 1 and 0.5 within this amount of time. And the script will constantly run. Like that happens so often that somebody made that library, that method that you can call for you. So, okay, moving back and forth in some values, that's not too complicated. But let's say, okay, the x value I want to change. I want it to go from 2 here. I want it to go over to 0.1 here. The z value, I want this at 0.2. I don't know. I'm just making up values, 1.5, and then go back. So how do I? Gets very complicated very fast. Like I can't just code that up and just figure out the math to go back and forth on this. So, but what the animation system allows you to is you can iterate very quickly. You just start messing around, see what works, what doesn't work. And if you really like it, then not only can you just say, okay, this is the animation that plays, you can now figure out, okay, if I break this apart, I look at just the x, and I say, oh, it's going from 1 and 10 frames, 0.5, and here's the value, here's the value. All right, that's what x is doing. What is y doing? I can figure that out. And then I can actually code this up. But I couldn't figure this out. These are tools for designers to really find really cool, interesting stuff. And if you choose to, then you can bring it into code. And I'll show you some reasons why you might want to do that. But I can look at this and say, all right, that's great. Now, what else can we do here? Well, in this situation, we can just look at the color. You're used to messing around with the color. So you can open that up and say, all right, red at this point, let's drop it down a lot. Let's go full blue here, or green, whatever, and then blue. Let's have it cycle back. And then maybe alpha, I can ramp it up and down. You can do rotation, position, and I'll show you that you can actually mess around with the children object. So if your prefab is multiple spheres and cubes, you can have them all just doing stuff. You can actually just grab everything. But let's just say at this point that we're happy. So I've created my animation, my one state. I go back to the animator. It actually created the state for me. We'll go into creating our own states, but when you do this process, stuff gets automated, like the state got created, got connected to an animation. You see there's a little link here. It's the first state. This is what we go to right away. So if I click play, notice that there's this blue line going back up and up. It's looping. This is the timeline for just this little animation, which is 1 second long. And here's what the object looks like when it's being played. It's great. So let's say I'm really happy with it. This prefab, I'm just going to click apply just in case. So now the prefab that lives outside the game scene is updated. I'm just going to turn it off or delete it. Now I have to make sure that what I'm spawning, let's just say instead of spheres for the first object, I'll just make it this cube for now. Click play. And now that's what I'm painting. Cool. So notice that it still gets its like random color assigned, and notice how the color does fluctuate. Like if I look at this one here, he is definitely fluctuating colors. So they are like inheriting some type of initial color from my script, and it looks like their colors are kind of randomly changing by the animation. But we have to be careful because if you're going to interact with certain parameters, certain fields with the animation system, you're actually restricted from changing those values with code. Because at the end of the day, all the animation system is doing is changing variables with code. And so it doesn't let you directly change variables with code and change it with animation, because they would fight each other. So you'll notice that if you try to change certain parts of this now with code, you're not able to do that. So I think if I use the slider here, right. So notice how the size doesn't update anymore because it's being overwritten. It's being driven by the animation system. So the glow still works. That's great. And it looks like the opacity doesn't work, and it looks like the color doesn't work anymore because it's being overwritten with the animation system. So you have to be very particular what you're going to drive with animation, what you're going to drive with code. And then this is what I was saying earlier on, that if you really, really like this feature, but you want to make it more dynamic, you want to make it changeable by the user, you can then go and change this and move from an animation to driving this effect with code, which is what I'll get to. Because I really like this. I think this is really cool, and I think it would be really interesting that if the user could mess around with the size as it's doing this, I think that it would be a fun feature. So I would like to move that way into Sprint 3. Maybe I'll do it in Sprint 4. I don't know. But if I clear this out, this is why I was messing around with rotations as well. Because rotations I'm not messing around with code. So even though rotations and scaling is still underneath the transform component, they're separate pieces of data. They're separate fields. So I can still animate on the rotation and still make the scale dynamic, still accessible to the user. But eventually what I'd like to get to is, combine the best of both worlds, which will be Sprint 4. So just be aware of that. And now that I'm showing you this, we get to talk about that if you do wish to create prefabs or create objects that have like multiple parts to it, children, you can access them as well through the animator. So that's why you have these cubes with these like spheres spinning around them. So let me go ahead and create that. So let me say I'm really happy with this. It's actually really cool. Oh, that brings me to something else. So I was animating one of these cubes, right? And I kind of was messing with it. I thought this looked interesting. And notice how when you generate many cubes at once with code, some different behavior is happening. Like, I didn't realize this is going to do that in the animator, right? So this is emergent phenomenon, emergent behavior. I didn't know how all these cubes are going to act kind of in this oscillating when they're all offset from each other. So that's the other part, our reason for the animation system, which other development packages have as well. Even if you're just like a straight up web dev, there's packages. Adobe's really famous with their web dev packages for that. Oh, Animate, Adobe Animate, stuff like this, where it'll kick out straight CSS code. So you have access to all these like nice design animation systems, and if you really like what you did, you click export. Export everything out in CSS or some web dev language that it's all nicely coded out for you. But the point is like I didn't. You come upon this is common in design studio. You come on like a happy coincidence. You didn't plan for this, but I like this. I'm gonna use it. So now that I know this can happen, so if I take one object and I say I like this animation, I can carry over that animation into code and know that if I spawn these, they're just being spawned every kind of offset, every millisecond or something, whatever the update loop is running out, maybe every 10th of a second. Something like this will happen. And if I do the animation via code and I know that this string of cubes will kind of make this emergent behavior phenomenon, if I do it all by code, I know that I can then grab the size slider and still add even more dynamic behavior by letting the user change the size of it while it's still fluctuating, which is where I'll aim to get to. But let me say I like this. I'm going to add a child component to it, a child object that I'm going to animate as well. So I'm going to take the cube. Oh, right. So I created a new prefab in my project, a separate file. In this case, it was cube with this animator on it. And under click detector, I don't know what you called your references. I called them painted object 0, 1, 2. But you just drag and drop. That's the point of having these references. They're like open links. And you can say connect to that, connect to this, connect to that, or whatever. In this case, it was connected to a sphere that was static. And I said, no, I don't want that anymore. I want you to connect to this cube that animates. That's just what you're linking to, what you're referencing. All right, so let's keep working on this cube. I'm going to bring it in again. Reset its position. That's very important because you have this random position information. And if you click apply or drag it back into your project, it's going to save that kind of offset. So make sure you're always zeroing out your position. But in any case, I've got this cube. I'm going to call it something else. I've been doing cube sphere. I'll do cube sphere again. I don't have just straight cube sphere. No. So I'm going to go game object, 3D, create a sphere. Make sure the position zeroed out. In this case it is. Drag it underneath it. And I'll just scale it down a little bit. And you know, I've always been doing this gray material. You know, this kind of looks pretty ugly. So I'm going to go into materials. And I don't, something that's not too strong. Try this blue. Sure, that's fine. So now if I go back to my, I'm in the same animation, no new animation. Add property. Notice now there's something else we can work with because this object has a child object or multiple child objects. They're all available, and you can open them up and look at their components. And I'm going to mess around with its transform. In fact, I'll mess around with its position. Sure. So this is my prefab. I just dragged it in. I just went game object 3D sphere. And then I'm zeroing out its position and then placing it underneath my prefab. So now it's a child. Very similar to when we built the clock. And then I just kind of scaled down the sphere and just moved it off to the side. And then I gave it a material from my material folder.
So that's one of the first cube. Or is that
yeah, so I'm going to make a new, I'm basically making a new prefab. So I dragged in a prefab and I'm making a child object too, and I'm morphing it. You can click apply and save, like overwrite your prefab like file, but I'm just gonna create a new one. I'm gonna show you. I'm gonna drag it up later on when I'm done. But anyway, I've got this cube that's like the parent, this sphere, and now I have access to animating on the sphere too because it's a child. It's within the hierarchy. So I'm just gonna go to its position. It sets my beginning and ending frame. And if I open up its position, Y is 0, Z is 0, and you know, X is offset, but that's because I moved it to the side. So that information has been recorded. So I drag it. Because the parent is doing its craziness, the sphere is coming along for the ride. Actually, let me see if I can just cut this. Oh, you know what? I'm just going to move it out. So it's too like over. I do want this effect. It's just too overwhelming right now. So I'm actually just going to select them all and move them off. And yes, I did like add. I'm going to move these back, even though it looks like I opened up my animation. I just kind of got it out of the way, and I want to just work in this space, and I'm going to move stuff back. So to start with, I'm going to want the sphere to rotate around, like orbit the cube. So we're, again, just working in this 0 to 1 space. At frame 30, run the left side of the cube. And if I just make that positive, run the right side. So now I have it moving back and forth. So half a second to the right, half a second back. So that means halfway through it moving fully through, we want it to move up. So I can go to Y and say, all right, you should be at 1 or like 1.2, whatever the numbers I was using. X was going, yeah, 1.2, negative 1.2 to 1.2. So now I'll do that on the Y. So it goes fully up, fully to the right. And in this case, Y needs to be 0. Or I could actually just go to here and say negative 1.2. So halfway in its left to right journey, it's going to be fully up. Halfway on its right to left, it's going to be fully down. So now we have an orbit, or a full circle. So So a few things to note is now I never talked about the curves yet. Let me talk about the curves. So we have down here we have dope sheet and curves. These are terms that are just coming from the animation industry. Dope sheet is like a whole graph paper. It's like an Excel sheet saying these are the values that it needs to be. It's only showing my key values, the ones that I'm placing down. Curves actually shows you the interpolation that the software is doing between those keyframes. So here we see all the actual points between each line. So if I look at just one, say sphere X, let me just zoom up to 1 second. Here we're going from negative 1.2 to 1.2 to negative 1.2. All right, full circle. So you can notice that the line has like a nice curve to it. It's parabolic, it's parametric or parabolic. The animation system does this by default. No, the animation people have found out that this nice curve interpolation between our points makes for this very organic feel to it. So I can show that if I select these points, oops, zoom out a little. There we go. You can change them. You can manually change these, and so for example, like this, you can change how that information interpolates. But if I just right click and just say linear, here is a linear interpolation. There's no nice curving, no nice like the numbers like kind of it's the acceleration that kind of levels out and then levels back down. So it feels like momentum, it feels like breathing. Here, this is straight linear interpolation. How many frames between this value and this value break up the division equally? So sometimes you do want this kind of very mechanic back and forth, but normally by default it gives you this nice, they call it ease in and out, this softening. So if I make this sphere move in a very linear fashion, very zigzaggy. This is going to be weird because I've got, let me try and cut, let me see if real quick, if I can just cut these frames out, if I can paste them again. I can, perfect. So I can cut them out so we don't have to worry about them right now. So now just the sphere is moving around the cube, but if I go back to its curves and press the F key, notice how the curves are very zigzaggy, very linear interpolation, and the actual movement is that way. We're getting this diamond-shaped movement, right? So if you ever needed to do that or wanted, just know that that's linear interpolation. That's not the default, because normally most of the time you want this nice soft easing in and out. So if I stop that and bring these back to, I think it was flat, notice how we're getting a smoother movement, a circular movement. We do have this hiccup that I'll address in a second. But notice that we're actually kind of like moving circularly, like a nice natural orbit. And that's what these curves are doing. So let me just look at one at a time. First off, when you click on everything, you can get, it's overwhelming, all these lines and everything. Never look at all these, animation all at once. Just look at like one little part. So here we're just looking at position of the sphere, and here we're just looking at the X position. Since I moved the sphere to the side to start with, so I decided to start the animation at its farthest, or in the X terms, the most min part, and we go to the max on the right and back to the min. We have a nice going from the bottom to the top to the bottom, right? The Y is a little offset. We start at almost like the midpoint. We go up to the peak, we go down to the bottom, and we stop at the midpoint again. That's just the way I design this. I built it. I moved the sphere to the side and decided to start from there. If I moved the sphere from the top, we would have had a nice Y animation starting from its height all the way to its bottom to its height again. And then X would have had this irregular issue. But Y, actually, the reason that there's this little hiccup every time it goes around is that we actually kind of have this rounding in a midpoint. We do want this nice curve at the top. We want this nice curve at the bottom. But it doesn't make sense to have this curve at the middle. In fact, if I zoom out, you see that the animation's repeated. We're getting this weird little mid, plateau. And that's what's causing that hiccup. So we actually do like a nice rounding here, nice rounding there. And I'm going to press the F key to frame up. But we don't want that rounding in that midway point. So you can manually just take the handle and even it out. Or you could just say right click and say linear. Either way. The end result being if I zoom back out, we got rid of that weird midway hill. So if I click play, now he's just going around. All right. So this was the sphere position on the X. And if I zoom out, and the Y, and they have these nice crescendos, nice ups and downs. And everything looks good. So just be aware that you'll sometimes maybe get those hiccups or whatever. And that's the reason for it. So there. I have my second animation. And hopefully, if I paste, nice. Looks like it saved all that other information. So I can just drag it back over. So these keyframes are just stored data positions. So data entries, these numbers. So you can copy and paste them just like you would anything else. So now I'm going to combine this. What's happening here? Is this some weird scaling? So somebody's moving too quick. So I'm going to look at each one real quick. X and Y looks good on the sphere. I think there's something crazy with the scaling. So X, Y, Z. I don't know what that is. I'm just going to move this one key. Oh, it looks like this was supposed to be the ending. Scale X of 1. This is supposed to be 1. I don't know, it's 0.1. Okay. So he's fast. I can, if I wanted to, actually, it's actually interesting. So let's say the animation's too fast. I can select everything, and I'm going to zoom out. I'm just going to drag it out to 2 seconds. I really like it. It's just, it's giving me, an aneurysm. It's too quick. But you see, I can select all the keys and drag the bar. It kind of scales everything out for me. So cool. All right. So let's say I'm happy. There seems to be a little pop in the scale right there. So I go to the curves. There it is. Z. Z is not starting and ending at the same. So let me go scale Z. I'm just watching the number 0.15. Oh, and it never returns back to 1. All right. So you see, as you start nesting animations, they can get complicated. So learning to troubleshoot and diagnose stuff is important. But anyway, I'm supposed to be getting toward the end of my lecture now. Anyway, so let's say I'm happy. I'm going to unclick preview. I'm going to get out of the animation. So here, I have my new prefab. So we should be good to go. So I'm going to drag this up into my prefabs. I'm going to go to my click detector script and overwrite this so I can take a look at it. I think it's this one. Click play. This one I'm going to have to get out. I'm going to have to hide it. Alright, I'm going to hide that and paint it. So here's what we got. So hopefully you think you have some ideas what you're going to mess around with. This was just an intro to animation. We're going to be spending quite a bit of time on just working within that animation window over these next 3 weeks. We're going to be creating more than just one animation and how to transition between them. That's actually probably going to be, and then the last thing was just like how to move your animation to code if you do choose to wish to dynamically still interact with it. Like for example, the size button doesn't work anymore. I think that's probably going to take us through the rest of the semester because it's a lot. So practice that with the video and then try making your own animations. If you can successfully make like one animation state and get it working in your paint stroke, you know that you're in good shape. And I will create another video talking about the specs for Sprint 3. Cool. Any questions? And I think, even though that animation, pretty sure this is sharing. Yep, it is. I just want to see if it still works. So could I go back to the original prefab? Yep. Cool. So this is still sharing the same animation that has the sphere in it, even though it's an older prefab that doesn't have the sphere object in it. Just so some prefabs objects can reshare animations. If I go to the animator, this one is still used on this cube one, and it's still on this cube sphere. It's the same controller, and just that part of the animation that deals with the sphere is kind of like hidden away. It's still usable on this other one. All right.